Good morning, Geometry Advanced students. So in this lesson, we are going to continue along with circles. We are going to focus today on arcs of a circle. So as you can see here on the screen, we're going to identify the different types of arcs, like major versus minor, determine the measure of an arc, so how many degrees it is, recognize when you have congruent arcs in a picture, and finally apply the relationships between the congruent arcs, chords, and central angles. So if we begin here, so the definition of an arc, it says an arc consists of 2 points on a circle and all points on the circle needed to connect the points by a single path. So if you're looking at my picture here, an arc, like it says here and it's darkened, we have arc AB. We have 2 points, A and B, and again, all the points on the circle need to connect it by a single path. The center of an arc is just the center of the circle. So in this picture, if I labeled this center point O here, that would be the center of the arc because it's also the center of your circle. Continuing on. A central angle is an angle whose vertex is at the center of the circle. So in this picture, angle ACB is a central angle. The vertex is at the center, which is point C. The sides are going to be radii of the circle. So segment AC and segment AB, and segment BC, sorry about that, are both radii of your circle, so they make a central angle. Now there's a difference. We talked about an arc, and I had mentioned in the beginning about major versus minor. So a minor arc is an arc whose points are on or between the sides of the central angle. So like it says here in the picture, your minor arc would be arc AB. Usually a minor arc is going to be less than half a circle or less than 180 degrees. A major arc is an arc whose points are on or outside the central angle, and usually we name them with 3 points. So this would be my major arc out here like it says, and then let's put a point out here, we'll call it D. So they would name, the way I would name my major arc would be arc ADB. You still have A as the beginning, B as the end, and then you have some point along the way. So again, major arc is basically inside the central angle. Major arc would be outside. And on a side note, the major and the minor arc together make a full circle of 360 degrees. Okay, last on this page is a semicircle. So a semicircle, most of us probably know that already, is basically half a circle. A semicircle is an arc whose endpoints are at the endpoints of the diameter. So in this picture, if segment AB is a diameter, that means arc AB is a semicircle. Now sometimes a semicircle is named with 3 points, sometimes 2. I feel like that's not always consistent depending on what site or what textbook you're looking at. So again, if you have 2 points that are the endpoints of a diameter, they form a semicircle when you go around the circle. Continuing on here, so let's talk about how to find the measure of a minor arc or semicircle. So it says the measure of a minor arc or semicircle is equal to the measure of the central angle that intercepts the arc. Okay. So in this picture here below, if angle FDE is 70 degrees, that means, according to that definition, that arc FE is also going to be 70 degrees because, again, it is the measure of the central angle. Now, to find the major arc, the measure of the major arc is 360 degrees minus the minor arc. So if I'm looking in this picture here for the measure of arc FGE, that would be the major one, I would take 360 and subtract off the minor arc, which is 70, so that leaves me with 290 degrees, again, for your major arc. So again, your major and your minor together make 360 degrees. Okay, continuing on here. So in this one, we are given that segment HK is perpendicular to segment HM. So that implies in the picture that we have a right angle there. If segment HM is 8 and the length of segment MN is 2, so if we pause for a moment, that would tell me that the radius of the outer circle would be 10 because 8 plus 2 is 10. So it says find the measure of arc LN. So arc LN, okay, is a minor arc. It's the same as the central angle. So since the lines, or the segments, I should say, are perpendicular, that means angle H is 90. So arc LN would be 90 degrees. And then arc KM, same kind of thing. It's just a different circle. It's a smaller circle. But again, if the central angle is 90, arc MN is also going to be, arc KM is also going to be 90 degrees because it's the same as the central angle. But the question below, it says, is arc LN congruent to arc KM? Well, they're both 90 degrees, but if you think about it, if you cut them, they're not going to match up exactly because they have different radii lengths for your circle. So are they congruent? My answer would be no, because the circles are not congruent. Okay, they have a different radii. So one of them has a radius of 8, the other one has a radius of 10. So even though they have the same degree, they are not going to be congruent. So if we take a look at our definition here below, it says if two arcs are congruent whenever they have the same measure, so again, they have to be the same degree. So again, they have the same measure and are parts, here's the second part, of the same circle, or they have to be congruent circles. So the ones we just looked at, they did not come from the same circle, and the circles were not congruent because we talked about in a previous lesson, for two circles to be congruent, they have to have the same radius. Like the radius length has to be the same. Maybe they both have a radius of 8 millimeters or something like that. So if I look at two options for pictures here, on the left, if they're in the same circle, we would have arc ON congruent to arc PQ. So again, arc ON would be congruent. Sorry, it's writing kind of slow. To arc PQ. The reason this works is because they come from the same circle and they're congruent. Both of them are 60 degrees. Now, if they come from separate circles, like you see in this picture on the right, let me scroll down here a little bit so you can see better. But again, it's telling me at the bottom here that we have congruent circles. So if the circles are congruent, and we need to pretend that these are both 60 degrees again, then we could say that arc TS is going to be congruent to arc WV. So again, if they come from either the same circle or congruent circles, and they have the same degree, then you can say that the arcs are congruent. Now before we try more examples, we have some theorems we need to cover that relates congruent arcs, congruent chords, and congruent central angles, and how everything is related. So we have 3 sets. Okay, so this first one is going to talk about how central angles and arcs are related. So it says if two central angles of a circle or of congruent circles are congruent, then their intercepted arcs are congruent. So again, if the central angles are congruent, the arcs are congruent. So in this picture, so again, if I was looking for a shorter way to write it, I would say if the central angles are congruent, then the intercepted arcs are congruent. So in my picture here, if we knew that angle, let's see here, angle AM, not B, sorry, let's try that again. Angle AMB is congruent to angle CMD. Then according to this theorem, then arc AB would be congruent to arc CD. So again, if the central angles are congruent, then the intercepted arcs are congruent. Now it works again both directions. So the converse of this theorem is also true. So if two arcs of a circle or of congruent circles are congruent, then their corresponding central angles are congruent as well. So again, it just goes in the other direction. So this would say if arc AB is congruent to arc CD, then the central angles are congruent. So then angle AMB would be congruent to angle CMD. So again, if the arcs are congruent, then the central angles are congruent. So it goes hand in hand. So that is the first set. The second set is going to relate chords and central angles. So it says if two central angles are congruent, then their corresponding chords are congruent. So again, as an abbreviated version, we would say if central angles are congruent, that implies that the corresponding chords are congruent. In my picture, if I said if, again, angle AMB is congruent to angle CMD, then again the chords would be congruent. So segment AB would be congruent to segment CD. That's what that tells us. The converse of that, again, is also true. So the converse would say if two chords of a circle are congruent, then the central angles have to be congruent. So again, just the converse. So we would say something like if segment AB is congruent to segment CD, then the angles. So angle AMB would be congruent to angle CMD. So again, if two chords are congruent, then the central angles are congruent. So if you think about how we've paired them up here, the first set was about central angles and arcs. The second one was about central angles and chords. So one would assume then what we have left is talking about arcs and chords. So the first direction says if two arcs of a circle are congruent, then their corresponding chords are congruent. So again, if the intercepted arcs are congruent, the corresponding chords are congruent. So if I'm looking at this picture, I would say if arc AB is congruent to arc CD, then the chords. So then segment AB would be congruent to segment CD. And the converse of that is true as well. So again, if two chords of a circle are congruent, then the corresponding arcs are congruent. So the other direction would be if segment AB is congruent to segment CD, then arc AB would be congruent to arc CD. So within these 6 theorems here, we've related in one direction or another how congruent arcs and congruent chords and congruent central angles are related to each other. So to finish off today's lesson, we're going to take a look at some examples. So we're going to take a look at one more example involving angles and arcs, and then we are going to finish with some proofs. So if we take a look at this page here, in the first example it says we are given that we have circle F and that angle GHF is 25 degrees. So we want to find arc HG. So to find arc AG, we need to know the central angle. So if we're thinking about it, this is an isosceles triangle because we know all radii of a circle are congruent. So if angle H is 25 degrees, that means angle G is also 25 degrees. And again, we should know that angles of a triangle have a sum of 180. So 25 and 25 make 50. So 180 minus 50 is 130. So if angle F here is 130, that tells us that arc HG is the same as that. So arc HG is also going to be 130 degrees. So it involves angles of a triangle as well as central angles and arcs and how everything is related. Okay, now if we take a look at our 2 proofs here for today. So the first one, I think I've got everything on the screen there. So we have circle D, and we have arc AT is congruent to arc RP. And actually, we have an extra line here. We don't really need them as proof. Okay, so again, these overlapping arcs are congruent. So the arc from A to T is going to be congruent from the arc from R to P. So because of that, hopefully you can make the conclusion that arc RT is going to be congruent to arc AP. Okay, what did we do? We used the subtraction property. What did I do? I subtracted this arc here that they overlapped. So if I subtract that from each one, those end arcs, arc RT and arc AP, are going to be congruent. Okay, and then one of our theorems we had for today says if 2 arcs are congruent, then the chords are congruent. Okay, so again, if we want to write that out, we would say if the intercepted arcs are congruent, then implies that the chords are congruent. So again, if intercepts and arcs are congruent, then implies that the chords are congruent. Okay, so let's take a look at our other proof then. So in this one, we are given that we have circle K that, let me scroll up here just a bit so we can read everything there. Segment PK is congruent to segment KQ. So we're going to mark that in the picture with some tick marks. And we are also given that segment JN is perpendicular to segment KP, and that segment LM is perpendicular to segment KQ. We are trying to prove that arc JM is going to be congruent to arc LN. So one way to think about this is if we could prove some chords are congruent. For example, if we could prove that segment LN is congruent, let me switch colors here, to segment ML, then we could say that these arcs from J to N is congruent to arc LM, and then we could use subtraction, hopefully you're thinking, to get to this. So to continue with our proof, after the given here, so hopefully you've noticed that segment JN and segment LM are chords, okay? From the first part of the given, if they are equidistant from the center, because we can see this with these segments being congruent, then the segments themselves are congruent. So I can state that segment JN is going to be congruent to segment LM. And my reason goes back from the congruent chords lesson, and it says something like this. If two chords are equidistant, from the center, then the chords are congruent. Again, that came from lesson 10.2. If two chords are equidistant from the center of a circle, then they are congruent. So we can now state that those two chords, JN and LM, are congruent. Okay, so because those two chords are congruent, we can then state that the arcs are congruent. So my next step is going to be stating that arc LN is congruent to arc LM. And again, my reason, we just talked about this earlier. If you have chords that are congruent, then the intercepted arcs are congruent. So again, if chords are congruent, the intercepted arcs are congruent. Okay, and if I go back and look at the picture, so again, if the arc from, let's get some color here, sorry about that, from L to M is congruent to the arc from M to L, then what you could do is subtract off this arc MN where they overlap, and then I'd be left with arc JM congruent to arc NL by subtraction. So again, I'm ready for my proof line, so I did not need this step of the proof. So I can state again, arc JM is congruent to arc NL by, again, subtraction, because we're subtracting off that piece. Okay, so we're going to finish for today's assignment. You have on page 454 numbers 6 through 13, and then numbers 16 and 18. And as always, if you have any questions, please let me know.